Lesson 2.2 is on multiplying polynomials. We're going to start off with some examples where we expand and simplify the product of polynomials. So we start off with our first example. We're multiplying a binomial with another binomial, 3x minus 4 times 2x plus 5. So the method we're going to do is we're going to multiply the first term in the first binomial with both the terms in the second binomial. So 3x gets multiplied with 2x and 5. And then we're going to multiply the second term in the first binomial, which is negative 4, with 2x plus 5. Once we've done that product, we're going to add like terms and simplify. So the first step is multiplication, which is the expansion step. So when you do this, there's three things you have to pay attention to. What is the sign? Is it positive or negative? What is the product? And then what is the variable part with its exponent, okay? So 3 times 2 is 6. X times x is x to the power of 2. So I don't have to write plus here because I'm starting with the positive. There's no need to write plus. But in each term, you have to decide if it's positive or negative, what's the coefficient, and then what's the variable part, okay? Then 3 times 5 is 15, so it's positive, plus 15, and then there is an x, so don't forget that. Now you're going to multiply negative 4 times 2x, so it's negative 8x, and negative 4 times 5, which is negative 20. Typically in these products, you'll find that the middle two terms are the like terms, so they can be added. So 15 minus 8x, 15x minus 8x is positive 7x, and then you have these three terms which are not like, so you can add them up, and that is a final answer. Second example here, you have a binomial multiplied with a trinomial. So it's kind of the same idea. It's just that each term in your first binomial will multiply with all the three terms in the second trinomial. So negative 10x gets multiplied with all of these three terms. So I'm just showing the arrows to kind of remember what I'm going to do. And then the positive 5 gets multiplied with all of these three terms. Okay? So again, pay attention to what is the sign, what is the coefficient, and what is the variable. So negative times negative is positive. 10 times 5 is 50. T times t squared is t to the power of 3. Negative 10 times 5 is negative 50. T times t is t squared. Negative 10 times 2.5, negative and positive, so it's negative. And 2.5 times 10 is 25. And then you have a t. So now we've multiplied the negative 10t with all of these three terms. Now we're going to multiply the 5 with all the three terms. So negative and positive is negative. 5 times 5 is 25t squared. 5 times 5 plus 25t. And 5 times 2.5, again, plus 12.5. So you can see that, you know, at this point, you can add the like terms. You can, the 50t cubed has no like terms, so it's by itself. The negative 50t squared and negative 25t squared are like terms, so you can add them. Negative 25t and plus 25t are like terms, and then you have plus 12.5. So your final answer, you have 50t cubed. You add these two, you get 75t squared. These cancel out, plus 12.5, and that's your final answer. Our second example, we have a rectangular box that has the dimensions x plus 1, x plus 2, and x plus 3, so length, width, and height. And it's asking you to find the volume of the box. So the volume of the box is basically length times width times height. And instead of giving you numbers for those dimensions, you're given binomials. Okay, so you're going to multiply the length, which is x plus 1, with the width, which is x plus 2, with the height, which is x plus 3. So we're not going to do all the three products in one step. We can multiply, say, these two together, get the trinomial when you multiply these two, and then multiply the x plus 3 with that and get the final answer. So let's do this binomial product. X times x is x squared. X times 2x is plus 2x. 1 times x is plus 1x, and 1 times 2 is 2, times x plus 3. And again, these two terms are alike, so you can add them up, and you're going to get x squared plus 3x, there's a plus there, plus 2 multiplied with x plus 3. So I'm just going to rewrite it, put the binomial first and then the trinomial, it's just switching them up. The product does not change, it stays the same. And so I'm going to now multiply the x with all the three terms in the second polynomial, and then repeat that with 3 multiplying with all the three terms in the second polynomial. So pay attention to the sign, the coefficient, and the variable. So x times x squared is x cubed, x times 3x is plus 3x squared, x times 2 is plus 2x. So when I'm doing this, I'm already thinking of the sign, the coefficient, and the variable, okay? Now 3 gets multiplied with all these three terms, so plus and plus, so plus 3x squared, 3 times 3 plus 9x, 3 times 2 plus 6. So you want to write down all the terms that are alike together. So there's no other term in x cubed but just that one. There's two terms with x squared. That's this 3x squared and this 3x squared. And there's two terms with x, which are the 2x and the 9x. And there's only one term, constant term 6. So these two can add, these two can add because they're alike. So you're going to get x cubed plus 6x squared plus 11x plus 6. Okay, so that's your final answer. That's the volume of the rectangular box. And you have to be careful that you follow the rules for exponents. When you're multiplying exponents, you can add the exponents. So if you're multiplying, say, x times x squared, this 2 plus 1 gives you 3. But you don't do that when you're adding them. So for example, if you're adding 3x squared and 3x squared, 3 plus 3 gives you 6, but you don't add the 2 plus 2 and write 4 here. Some students do that, and that's wrong. So pay attention that you don't make those mistakes. Third example is 2x squared plus 3y plus 4z, the square of that, equal to 4x squared plus 9y squared plus 16z squared. So it's asking you to check and see if the left side is equal to the right side. I'm going to do this in two ways. I'm going to do first method, where I'm going to just assign values to these variables and then check if the square of that equals this right-hand expression. And I really don't want to give values to x, y, and z that are very big or negative, so that my work is much simpler. So I'm going to say let x, y, z be 1. So what would my left side be if the values of x, y, and z are 1? It would simply be 2 times 1 squared plus 3 times 1 plus 4 times 1, and that whole thing is also squared, right? There's a square there. So this is going to be 2 times 1 squared is 2, plus 3 times 1 is 3, plus 4 times 1 is 4. So it's basically going to be the square of 9, right? 4 plus 3 is 7, plus 2 is 9, which is 81. And now my right side, I'm going to do the same thing, assign the same values to x, y, and z. So it'll be 4 times 1 squared plus, if you can't see it, but 4 times 1 squared plus 9 times 1 squared plus 16 times 1 squared. Okay, so 9 times 1 squared plus 16 times 1 squared. So that's 4 plus 9 plus 16, and when I add them up, I get 29. So you notice that the left side is not equal to the right side when I assign those values to x, y, and z. So therefore, the statement that they have given me is not true. So therefore, the statement is not true. The given statement is not true. Okay. Now you have this one here. Another way to do this is take this trinomial and expand it. So like actually do the long way, which is multiply the 2x squared plus 3y plus 4z with another trinomial, 2x squared plus 3y plus 4z. And do all of that, expand, simplify, and see if you get this answer in the end. It's a lot more work, but it's also another way of checking. So 2x squared gets multiplied with all of these three terms, right? Then 3y gets multiplied with all of these three terms. And then 4z gets multiplied with all of them. So 4z gets multiplied with this, gets multiplied with this, and gets multiplied with this. You know what I'm saying, right? You get the idea. So I'm just going to move this down to have some room here. So 2 times 2 is 4x to the power 4. So if you notice, I'm just going to do this from left to right, and each time I'm going to pay attention to the sign, then the product, and then the variables, okay? So 2 times 3 is 6x squared y plus 2 times 4 is 8x squared z. So I finished the first one. Now I'm going to multiply 3y with all of these 3. So I'm going to get 3 times 2 is 6x squared y. So you always write the x, y, z in that order, okay? Plus 3 times 3 is 9, y times y is y squared, plus, I'm going to write here because I don't have room there, 3 times 4 is 12, yz. So I finished multiplying 3y with all of these 3. And the last one is multiply 4z with all of these 3. So 4 times 2 plus, it's positive, 4 times 2 is 8, x squared z, plus 4 times 3 is 12, yz, plus 4 times 4 is 16z squared. And you're going to find that when you simplify and add like terms, there's only one term with the degree 4, so there's nothing to add with that. And you have x squared y, and you have any other x squared y terms. 6x squared, 2 times 2. Oh, there's one y here, I forgot that. 2x squared plus 3y was, yeah, this 6x squared y and this x squared y gives me 12x squared y. Okay, I forgot the y, that was my mistake. And then the x squared z term, I'm just going to give it a different color. X squared z term, there's this term and there's this term. So these two can add up and I get plus 16x squared z. Then I have two terms with y and z, which is yz and yz. So that's going to give me 24yz when I add them. And there's only one term with y squared, so that's plus 9y squared plus 16z squared. And this has 1, 2, 3, 4, 5, 6 terms. It's nothing like this. This has only 3 terms. So therefore, the left side, you know, this left side is not equal to the right side. So you can tell that the given statement is also not correct. So there's two ways to do it. Either assign values to the variables and see if the left side equals the right side, or do the expansion simplifying and see if the left side equals the right side. Our next example is a word problem. You have a rectangle that is twice as long as it is wide. Predict how the area will change if the length is increased by 1 and the width is decreased by 1. Write an expression for the area change and interpret the results. So that's quite heavy. It's a lot of parts to this question. So the first thing you want to do is you want to draw the diagram. This diagram is actually not given to you. I'm drawing it now here. So you have this rectangle. I'm just calling it A1. And it says that it's twice as long as it's wide. So let's give a statement. Let the width of the rectangle be W, right? And then instead of writing the length the L, we're going to write the length in terms of the relationship it has with the width, and therefore the length will be 2 times W, or 2W, because it's twice as long as it's wide. It's given to us in the question. So if that is the case, what is the area of this rectangle? It's going to be length times width, right? Which is 2W times W. I'm not putting, multiplication, the symbol as X, because it gets confusing with the variable X. So the area of this rectangle is 2W squared, okay? And it's asking here, predict how the area will change if I now change the dimension. So I'm going to increase the length by 1 and decrease the width by W. So this second rectangle I have here is like a diagram where I've changed the dimension. So I've increased the length by 1, so it's 2w plus 1 per length now, and decreased the width by 1, so it's w minus 1. So what is the new area going to be? It says write an expression for the area change and interpret the result. So before I can find the change in area, I have to know what the area becomes. Okay, so what is A2? So A2 is again length times width. So it's going to be w minus 1 times 2w plus 1. So you have now here two binomials and you have to multiply them. So w gets multiplied with that, and negative 1 gets multiplied with that and that. So you get 2w times w, which is 2w squared. W times 1 is 1w, minus 2w times 1 is 2w, and minus and plus is minus. 1 times 1 is 1. So again, you can see that these two terms are alike. So you can simplify by adding those middle terms, and you get 2w squared minus w minus 1. Okay, 1 minus 2 is negative 1, so minus 1w. So the question did not ask me to find just the new areas, you know, A1 and A2. It's asked me to write an expression for the area change and interpret the result. So the area change is, you know, is what happens when you find the difference between A2 and A1. So how much has it increased or decreased? Okay, so I'm going to subtract the two areas to see what the area changes. So the second area is 2w squared minus 1w minus 1. Subtract the old area, which is 2w squared. Okay, so this is like our lesson 2.1. What happens when you open up the brackets? The second one, you distribute the negative 1 into brackets, you get negative 2w squared. And then when you add like terms, this 2w squared and minus 2w squared added to 0, they cancel out. And your change in area is negative w minus 1. And that's basically, if I factor out the negative, it's negative of w plus 1. So you can see that the area change is negative. So since A2 minus A1 is negative or less than 0, what does it mean? When you subtract A2 minus A1 and you get a negative answer, that means the area of A2 is less than the area of A1. So therefore, area of A2 is less than the area of A1. So when you increase the width, the length by 1 and you decrease the width by 1, you actually end up with an area that's less. That's why when you subtracted A2 minus A1, you got a negative answer. Okay, so that is the interpretation of the result. Okay, they asked you to interpret the result. The interpretation is that the second area is less than the first area. Okay, now you want to do the homework questions.